So this is another question from IIT JEE PYQ. The question is from the chapter Newton laws of motion here and friction. And here is the question. Masses m1, m2 and m3 are connected by strings of negligible mass which pass over massless and frictionless pulleys P1 and P2. Okay, as shown in the figure. The P1 and P2 is parallel to the inclined plane and the portion of the string between this P2 and M3 is horizontal. Okay, so this portion is horizontal here and this portion is parallel to this inclined plane. Right, now the masses M2 and M3 are 4 kg each. So this is 4 kg mass here and this M3 is also 4 kg. And coefficient of kinetic friction between the masses and the surfaces is that mu kinetic friction, that is equal to 0.25. The inclined plane makes an angle 37 degree with the horizontal if the mass is m1. If the mass m1 is here, m1 moves downward with the uniform velocity, then we have to find the mass m1 and the tension in the horizontal portion of the string. Okay, so this is a simple question actually. I will draw the diagrams here. Here it is mentioned that the m1 mass is moving in downward direction with an uniform velocity. Uniform velocity means that means velocity is constant. Okay, velocity constant means acceleration is 0. So this mass m1 is having 0 acceleration in downward direction. It is moving with a uniform velocity only. Okay, so if I consider here, let us suppose here in this string tension is T1 and in the horizontal part of the string tension is T2, right? Now if I draw the free body diagram for this m1, then let us suppose this is our block of mass m1 here, and what are the forces acting on it? One will be m1g in downward direction. Okay, one will be the tension force T1 in the upward direction. Since acceleration of this block is 0, then I can write the equation of motion that T1 is equal to what? M1 into G. Let me suppose it is the equation number 1 here, right? Similarly, if I draw, this is our inclined plane here, right? And this angle is theta, let us suppose, and theta is given as 37 degree, right? We will substitute this value later. Now this is our block of mass m2. Now what are the forces acting on this block, right? So what are the forces? Since this block is moving in this direction with an uniform velocity, that means acceleration is equal to 0, right? So here this is m2g due to the gravitational pull, that is the weight of this m2. Okay, and this will be a normal force acting in this direction. Since this angle is also equal to theta, so this will be m2g cos theta, right? There will be a tension force T1 in upward direction and there will be a tension force T2 in downward direction, right? Since this block is moving in upward direction, so there will be a friction force also in downward direction. So let us suppose this is a friction force F2. F2 is the friction force acting on this block. And what is the value of this F2 will be? That is mu kinetic friction multiply this normal. And the value of normal is what? Normal is m2g cos theta, right? So here I can write the equation of motion for this block, that upward force will be equal to downward force. That means what? Acceleration of this block will be equal to 0. So here tension T1 is equal to, tension T1 will be balancing two forces, that is equal to T2 plus this friction force F2, right? So here the value of T1 we already know from the equation number, that m1g, or we will substitute it later. I will directly writing the equations only here. T1 will be equal to T2 plus the value of F2, that is the friction force on M2 block. F2 is equal to here mu k multiply this normal force, that is m2g cos theta, right? So this is our equation number 2. Let us pause. Now coming to this third block m3. Okay, so I am drawing the free body diagram for this m3. This is our m3 block, m3, and there will be a weight of this body acting in downward direction, that is equal to m3g. Okay, and there will be a normal force acting in upward direction due to the contact with the surface. There will be a tension force in the horizontal part of the string, that is equal to T2. Okay, and there will be a friction force acting on this body, that is equal to F kinetic, and let me say this is the F3 force. Okay, so here the value of F3 will be equal to what? Mu kinetic multiply this normal force, and normal force is balanced by m3 into g, that m3 into g. Okay, so mu kinetic that will be multiplied by m3 into g. This is the friction force. So here I can substitute the values of mu k, m3 and g. Okay, so let me see here. The value of mu k is 0.25 and m3 is 4 kg, right? So F3 will be equal to what? Mu k is 0.25 multiply m3 is what? 4 kg multiply 10. Okay, so this will be equal to this 0.25 I can write, that will be 1 by 4 multiply 4 multiply 10. So 4 will be cancelled out, so m3 will be equal to so this friction force on m3 will be equal to 10 Newton. So this F3k is equal to 10 Newton. Now since this block is moving in this direction with uniform velocity, that is v is equal to constant, so acceleration is equal to 0. So in this case, if I write the equation of motion for this object for this m3, then T2 force will be balancing this friction force F3. Okay, so T2, the value of T2 I am getting from here, that is equal to what? Wait, the value of T3 is equal to the friction force acting on this block, that is equal to 10 Newton. Okay, so the value of T2 is 10 Newton here. Now if I come to this equation number 2, if I write from equation number 2, if I write this equation here, T1 is equal to T2 plus this mu k m2g cos theta, mu k m2g cos theta. Okay, sorry, here one more force we did not mention here. One will be a component of this mg in this direction, that will be equal to m2g sin theta. Okay, so this T1 force will be balancing all of these components, m2g sin theta. So here we have to plus one more force, plus m2g sin theta, and here also plus m2g sin theta. Okay, so this is our equation number 2. So if I write this equation number 2 completely here, then it will be equal to T2 plus mu k m2g cos theta plus m2g sin theta. Okay, so here the value of T2 we already know, that is equal to 10 Newton we have calculated, and the mu k value we already know, 0.25, and m2 all values we know. So here we can find out the value of T1, that will be equal to the value of T2 is what? 10 Newton plus the value of this mu k is 0.25 multiply this m2 is what? 4 Newton, 4 kg multiply this g is what? 10 multiply cos theta. So here theta is equal to, we have to put 37 degree, right? So here the value of cos theta is what? Cos theta is given here sin theta is given 3 by 5, so cos theta will be equal to 4 by 5. Okay, here in question it is mentioned that sin 37 is equal to 3 by 5, so cos 37 will be equal to 4 by 5. From that right angle triangle we can easily find. So here we are putting the value of this cos theta, cos 37, that is equal to 4 by 5, right? Now plus the value of this m2g is what? 4 multiply 10 into sine theta, that is equal to 3 by 5. So now we just have to add these values and we will be finding the value of t1 here, that will be equal to what? The value of t1 is equal to 10 plus this 0.25 will be cancelled out by this 4 and this will be 2, so this term will be 8 plus this will be 5 into 2, so 4 multiply 2 is 8 multiply 3 is 24. So the value of t1 we are getting here, that is equal to 10 plus 8, 18, 18 plus 24, 18 plus 24, that is equal to what? 18 plus 24, that is equal to what? 8, 4, 2, this will be 2, 2 plus 2, 4, 18, 24 plus, so it will be equal to 4, okay, 42. So 18 plus 24 is 34 plus 8, 42, okay, 42 Newton. So this is the tension in the string that is parallel to this inclined plane. So here T1 value we already got. Now from equation number 1, if I write the equation number 1, from equation 1 we already know that T1 is equal to m1 into g, okay. So here the value of T1 we are getting is 42 Newton, okay. So this 42 Newton, that is equal to what? m1 into the value of g is 10 meter per second square. So the value of m1 will be equal to what? 42 divided by 10 kg, that is m1 will be equal to 4.2 kg, okay. So this is our answer for first part, and here the first part is we have to calculate the mass m1, so m1 will be equal to 4.2 kg, and the tension in the horizontal portion of the string and okay, tension in the horizontal portion of the string is 10 Newton we are getting. Actually we had to use here the value of G, I did not see here. G we had to use 9.8, and since we are using 10, so we are getting this F3 is equal to 10 Newton, that is equal to T3. If we use G is equal to 9.8 meter per second square, then our tension value will be equal to 9.8 Newton, okay. So that thing we can see, but it is okay, we are using here, we have used G is equal to 10 meter per second square in the question.